Hey, what's up, guys? John here again. So today, as promised, let's take a look at this meeting room problem number 253, meeting rooms number two. So, on LeetCode, there are like a series of different meeting room problems, or you can call it interval problems, right? Basically, you're always given like a list of the intervals. In this case, it's the start and end time. Okay. So, and for this one, they're all like the start time and end time, they're all inclusive. Okay. And then this is like a very classic question. It basically asks you to find the minimum number of conference room that's required to basically to host all this kind of meetings. Okay. So for example, this one, right? So you need a meeting room one, like room one to host 0 to 13, right? 0 to 13. And then you need another meeting room two to host 5 to 10 because they have like intervals based intersections, right? So you need another one to host 5 and 10. Okay. And then for the third 15 and 20, right? You can reuse the same meeting room two here because those two they don't have any uh, intersection. Okay. So basically, actually, so this problem is it's the same as the basically what's the maximum, right? What's the maximum intersection? What's the maximum intersection, right? Across all the intervals. Okay. So in this case, it's like 15, 20, right? Yeah. So it's the same as the trying to get the most intersections, right? The max intersections. So in this case, it's two, right? That's why the answer is two. So this one, since there's no intersection, that's why the answer is one. Okay. So for this kind of like intervals problem, a common strategy is we either sort. We basically not common. We always need to sort, right? Either sort the start date or the end date. Okay. And for this like minimum number of conference room required, we need to sort by the start date. Okay. So we sort by the start date, and then every time when we have like when we see a new meetings, right? And not we have besides the start date, we also have like an end date. Okay. Let's say for example, so if after sorting by the start date, we have a meeting room one here, right? Oh, sorry, we have a meeting one here at 0 to 30, and now we have an ending time of 30. Okay. Now the second one is 5 to 10. Okay. So we have a 5 to 10, and every time when we have a new start date here, right? We basically will be checking if there's any rooms that we can reuse. Okay, so to be able to find the room to reuse, we need to find the meeting that ends the earliest. Okay, so to be able to find, I mean, which meeting will be ending earliest, right? Across for the meetings that we have already scheduled before, we need to sort. We need to sort by the end date, right? How can we sort by the end date? We can use the priority queue. Basically, every time when we see a new meetings, we push we push this new ending time to that priority queue, so that every time when we have a new meeting start time here, we can always look for the first element of the priority queue, right? And the first element will give us the earliest ending time, right? And we will know that, and uh, basically we know how many, if we can reuse any of the meeting rooms, right? And if we can reuse that, basically we'll basically pop that will pop that earliest ending time from the priority queue. Okay, and in the end, the length of the priority queue will simply be our answer here. So why is that? Let's see. So we have a priority queue. Okay, so that's the priority queue. The first time, the priority queue will have 30 in it. Okay. Second time, the second meeting is 5. We see it's 5 greater than the earliest ending time, which is not, right? That's why we will be pushing this 10 into the priority queue. Now the first element in the priority queue will become to 10 and 30. Okay. So basically the maximum priority queue uh, actually the maximum length of the priority queue means the mi the maximum intervals, right, we'll ever get, right? Okay. Okay, now let's continue. So now we have 15 here, right? So the 15 is greater than 10. Okay. Then we know, okay, so we can reuse one of the endings, the meeting room whose ending is 10. Now we just remove it from the 10, remove it from priority queue, and then we push the 20 into it. Okay. Yeah. So that's in the end, I think I mean, we can either like return the length in the end, or we can just every time when we have a new meeting room, we just check the length of the priority queue. I think either way is fine. Yeah, we can either check I think for this problem, we can just simply check the length of the priority queue in the end, because that will be our final state, right? Mm, yeah, cool. Pretty straightforward. Let's try to implement this thing. So, and first we need to sort by start time, right? So we can simply do a sort, right? Because by default, right, it will be sorted by the first element and then the second element, which is the sortings we need, right? So we don't need to do a lambda functions here. And then priority queue, okay? So so for intervals, right? For intervals, actually start and in intervals, okay? And uh, if start mm, if not priority queue, okay? If there's nothing in the priority queue, we simply do a priority queue dot append, the end time, okay? So that's the first step. Else what? Else we check, right? We check the if the start, else if the start is equal uh, greater or equal than the priority queue 0, okay? Because the first element will always be the smallest in the priority queue, right? If that's the case, we will do a uh, heap queue dot heap pop, okay? Priority queue, right? This means that, I mean, we can reuse, since the start time is later than the earliest ending meeting room, which means we can reuse that, right? So we just push that. Oh, sorry, then we just pop this like the smallest, the earliest ending room from the priority queue, and then in the end we just do a heap queue dot heap push, right? Priority queue dot end. Okay. In the end, we simply return the length of the priority queue. Yeah, I think that should just work. Okay. Run the code. Okay. thing. Yeah, cool. Yeah, pretty straightforward, right? I mean, it's not a it's not a hard one, but it's a very classic one. So I think you guys need to master or remember or understand the concept of this kind of like intervals problem. You always sort by the start time, right? That in that case, you can basically which meetings I mean which meeting starts, I mean, what's the sequence of the start meetings, right? But besides the starting time, you also need to keep like keep another like data structure that can tells you which meeting ends the first. Okay. And every time when the meeting ends, right, the earliest end meeting, and then you can just use the current start time to check, okay, if we need a new meeting room or not. Okay. So the time complexity is actually the sorting itself, right? So the sorting itself is already unlog n here. Okay. And here we have a n here, right? And to uh, to do a heap pop and heap push, right? It's a log n. So here's an n log n. The for loop is also a n log n. So in total, it's also n log n. And the priority queue here, it's the space complexity is O of n. Okay, yeah, because the worst case scenario, right? So the worst case scenarios, we need to push everything. Basically, we'll be pushing everything into the priority queue. If there's no meeting room we can reuse, basically we'll just keep pushing all the meetings into this priority queue. So the worst case scenario, we'll be needing n meeting rooms. So where in that case the size of the priority queue will be the size of n. That's why the space complexity will be O n here. Yeah, cool. I think that's pretty much I wanna talk about for this problem. Very classic one. It's not a hard one, but it's a very important one. So I hope you guys can really understand. I mean the thinking process behind this kind of like intervals or meeting room problems and how you can utilize the sortings and then uh, and also be able to get the earliest ending meetings, right, among all the scheduled meetings. Cool. I think that's pretty much it. Thank you so much for watching the videos, guys. Stay tuned. See you guys soon. Bye bye.